When we're trying to find the area between two curves, we have the same concern that we had when we're trying to find the area between a curve and the x-axis. Does the difference between the two functions ever become negative? Right? We try to avoid that. We try to say, the top function minus the bottom function. But what if they change position? All right, for example, take a look at these two functions here. Just starting off with some very basic ones. Y equals x looks like this. And y equals 2 looks like this. And we're trying to find the area between 0 and 4. 1, 2, 3, 4. So you see what happens here, right? On the left side of our interval here, the y equals 2 graph is on the top, so we would want to do 2 minus x, but there comes a point here, right here in the middle, where the two switch, and the y equals x graph becomes the top one. Okay, so how do we deal with this? Well, we're going to use a very similar method to what we used when we were doing this with the x-axis. I need to know at what point do these two lines meet, right? Because that's the point that I'm going to use to split my interval, right? And then I'll do two integrals, just like we did before. So these two meet. I'm going to set the two y coordinates equal to each other. And like I said, we're going to start with a pretty straightforward example. X equals 2 is this point here where the lines meet. So what I'm going to do to find the area, I'm going to do two integrals. First, I'm going to do the integral from 0 to 2 plus the integral from 2 to 4. So on the 0 to 2 side, y equals 2 is on top. So I'm going to do 2 minus x dx. And then on the 2 to 4 section, the y equals x function is on top. So I'll do x minus 2 dx. Right, now that we've got the integral straightened out, right, it's just the same thing we've been doing all along here. I need some antiderivatives, so I'm going to do 2x minus x squared over 2 from 0 to 2 plus x squared over 2 minus 2x from 2 to 4. All right, now let's put our numbers in. When I put 2 in, this is 2 times 2 minus 2 squared over 2 minus, and when I put 0 into either of these expressions here, it comes out to 0. Plus 4 squared over 2 minus 2 times 4 minus 2 squared over 2 minus 2 times 2, and now it's just an arithmetic problem. So see, this is 4. 2 squared over 2, that's 4 over 2, so that's minus 2, plus 4 squared over 2, that's 16 over 2, that's 8, minus 8, minus 2 squared over 2 is 2, minus 4. All right, so let's see. 8 minus 8, let's just let those cancel, that's 0. 4 minus 2 is 2, minus 2, and we end up with 4. Right, that is the area between these two curves. And we can check this. Right, we can check this real quick because these two individual pieces here, columns section 1 and section 2, they're both triangles. Right? In fact, they're congruent triangles. They're the same, so they have the same area. Let's see, the base here is 2, and the height here is 2. So the area of one triangle is 1/2 2 times 2, which is 2. And if we double that because the two triangles are the same, yeah, we get 4. Good. Right, which is the same thing we got from splitting up the integral. Okay, so how about this one? What's going on here? Well, what do these things look like? Y equals 1 over x plus 1. That's got an asymptote here at 0. Y equals 0. Another one here at -1. So the graph, I'm looking between 0 and 4, so I just care about this right-hand branch. It's going to look like this. And the other one, that's a line, right? The y-intercept is -1/2, and the slope is 1/2, so it's relatively shallow. Goes something like this. And I want the area between 0, that's here, and 4. 1, 2, 3, 4. And you can see how, yeah, the lines do switch places. Okay, so the first thing I need to know is where do these lines cross? So I'm going to set the two functions equal to each other. 1 over x plus 1 equals x minus 1 over 2. And then let's see, we'll cross multiply. X plus 1 times x minus 2. Sorry, got ahead of myself. X minus 1 equals 2. So x squared minus 1 equals 2. X squared equals 3. X is the square root of 3. And I just want the positive one, right? Because we're over on the right side of the y-axis. So our x value range is just positive numbers. Okay, so let's see. I'm going to do the integral from 0 to 3. Who's on top on the left side of the interval? That's 1 over x plus 1 minus x over 2 minus a half dx. Whoops, not 3. 0 to the square root of 3 plus the integral from the square root of 3 to 4, and now we're just going to do them the other way around. Right? We'll do x over 2 minus a half minus 1 over x plus 1 dx. Okay, so let's see. Antiderivatives. This part is the ln of x plus 1 minus x squared over 4 plus x over 2 from 0 to the square root of 3 plus, let's see, x squared over 4 minus x over 2 minus the ln of x plus 1 from the square root of 3 out to 4. Okay, well, let's see. This is the log of the square root of 3 plus 1 minus the square root of 3 squared. That's just 3, so that's 3/4 plus the square root of 3 over 2 minus, and when you put 0 in, we get the natural log of 1, which is 0, minus 0 squared over 4 plus 0 over 2. So that whole part is just 0. Okay, that part at least came out kind of nice. Now, let's do the other side. 4 squared over 4 minus 4 over 2 minus the log of 5 minus, now I put the square root of 3 in, so that's 3/4 minus the square root of 3 over 2 minus the log of the square root of 3 plus 1. Okay. Let's see. I'm just going to save space, I'm going to do a little simplifying here. 4 squared over 4, that's 16 over 4, which is 4. And 4 over 2 is 2. So let's see. I get 4 minus 2, that's positive 2. I don't want to try to, don't skip too many steps. You'll mess yourself up. So let's just go ahead and write it out. Log square root of 3 plus 1 minus 3/4 plus the square root of 3 over 2 plus 2 minus the log of 5 minus 3/4 plus the square root of 3 over 2 plus the log of the square root of 3 plus 1. So let's see. Now we can combine some things here. Minus 3/4 minus 3/4 is minus 6/4. So that's minus 3/2. Now let's keep track of what I've touched. Right? Square root of 3 over 2 plus the square root of 3 over 2 is the square root of 3. So those parts are gone. Then combine the two logarithms. This is plus 2 log square root of 3 plus 1 plus 2 minus the log of 5. Okay, 2 is, if I do a common denominator here, 2 is 4/2. So 4/2 minus 3/2 is 1/2 plus the square root of 3 plus, and let's use some logarithm properties. Let's bring the 2 inside here. This is the log of the square root of 3 plus 1. And then I'm going to bring this log of 5 in here as well, over 5. And that's it. That's all, pretty sure, all the simplifying I can do here. Right, so that's not very pretty, but that's going to be my final answer. Okay, so I got one more here. Why don't you try this one, right? Pause it, see if you can work this one out, then we'll do it together. Okay, so first, I'm going to set these two functions equal to each other. The square root of x equals x times the square root of x. And so let's see, let's set this equal to 0. Square root of x minus x times the square root of x. And now let's factor that square root of x out. Square root of x times 1 minus x equals 0, which is good. I get two answers. This first factor gives me x equals 0, and the second one gives me x equals 1. Okay, awesome. One of those was our endpoint already, and the other one is in between these two. So that's how I'm going to split this. I'm going to make this the integral from 0 to 1, and over here plus the integral from 1 to 3. Now I'm in a little bit of trouble. I don't know who's on top. And I'm not going to worry about who's on top, honestly. I'm gonna do what we've done previously. I'm just going to subtract the two, work out the two integrals, and one of them is going to come out negative. Right? The one that comes out negative is the one that, okay, maybe I should have had the other way around. But again, I'm going to do what we did before. I know I just want the positive value. I'm just going to go back and backfill, put some absolute value around it. So I'm going to do, let's see, x to the 1/2 minus x to the 3/2 dx. Right? I'm doing fractional exponents, right? This one is x to the 1/2. This one is x to the 3/2. Then I get the same thing here. X to the 1/2 minus x to the 3/2 dx. Okay, so let's see where we're going to do our thing, right? Increase the exponent by 1. So this exponent goes from 1/2 to 3/2. So this is x to the 3/2 over 3/2 minus x to the 5/2 over 5/2 from 0 to 1. Plus, it's going to be the same thing. X to the 3/2 over 3/2 minus x to the 5/2 over 5/2 from 1 to 3. Okay, let's put some numbers in. This becomes 1 over 3/2 minus 1 over 5 halves. And if you put 0 in there, they both become 0. It's minus 0. Plus, now if I put 3 in here, this is 3 to the 3 halves over 3 halves, minus 3 to the 5 halves over 5 halves, minus 1 over 3 halves minus 1 over 5 halves. Okay, so let's say now we got some cleaning up to do. This is 2/3 minus 2/5 minus 0 plus 2 times 3 to the 3 halves over 3 minus 2 times 3 to the 5 halves over 5 minus 2/3 minus 2/5. Okay, 2/3 minus 2/5. This is, I mean, gotta do a common denominator. This is 10 15ths, and 2/5 is 6 15ths. I'm going to do the same thing in here. This is 10 15ths and 6 15ths. Now look at what happens on this part. This part is 4 15ths plus, I'm going to group this. I can tell the first part came out positive, right? So 99% sure this second part is going to be the part that comes out negative, and I got to stick some absolute value on. So this is 2. I'm going to reduce the 3 2 to the. I'm going to reduce the 3 to the 3 halves and the 3. So this is just the square root of 3 minus, and okay, this one I got nothing. 2 times 3 to the 5 halves over 5 minus, and I already know, right, this came out to 4 15ths. So that's minus 4 15ths. And I would trust myself and say that's negative. But look, if you're not sure, that's fine. Go to your calculator. My calculator tells me that is negative 3.04. So yeah, that is the part that's negative. So I'm going to do my backfill here. I'm going to put absolute value around all of these. And there, and that's going to fix it. But I don't want to leave it at that because I want to simplify more. So remember how we do this. How do you simplify an absolute value? If I have something like the absolute value of negative 3, how do I simplify this? Well, yeah, you know it's positive 3, right? But how do we get there algebraically? Well, what you do is you take the thing inside the absolute value and multiply it by a minus sign. So that's what I'm going to do here. I'm going to make this 4 15ths minus 2 times the square root of 3 plus 2 times the square root of 3 to the 5th over 5 plus 4 15ths. Now I can combine some stuff, right? 4 15ths plus 4 15ths. I'm going to jump way up here for the final answer. That's 8 15ths minus 2 times the square root of 3 plus 2 times the square root of 3 to the 5th. That's 243 over 5. And that's it. That's my final answer. Not very pretty, but hopefully you're starting to get used to that a little bit now, right? Because these area problems, these definite integral problems, yeah, you get weird roots and you get weird fractions, and yeah, they sometimes come out kind of weird looking. That's okay, right? It's still a valid answer. Okay, so where are we going to go next? Well, we've more or less exhausted what we're going to do in terms of the area between curves. All right, so we do have one more topic we're going to talk about. We really are almost to the end of the class here. I know I said we're not going to talk much about applications, but I do want to talk about one kind of a mathematical application of these integrals, right? It's called a separable differential equation.